So before that, let me introduce myself. Basically, I'm Bipin Yadav. I'm the employee of Xenstack Solution India Private Limited. So I'm here as a DevOps engineer. So let's move further. We'll proceed further with one of the DevOps tools. We call it as Docker. Guys, let me know once you can see my screen.
Sure.
Yeah. Is the screen visible now?
Yeah.
Okay, great, good. So basically, as I said, we're gonna start with Docker, and first of all, let me know. Have you heard about Docker previously or somewhere? Anything? I want to just know about from your idea what you know exactly till now.
Supreet did mention a couple of times about Docker with relation to containerization.
Yeah, yeah, you are absolutely right. So basically, Docker is based upon you can say containerization in that we deploy our microservices. So that's what we're gonna start in today's session. So basically, giving you an overview about Docker is you can say it's a you can say it's a minimal version of operating system in which you can deploy your applications. So it required a very less amount of resources. So later on we'll explain you how this overall works. So basically, Docker helps a developer to build a lightweight or you can say portable software containers that simplifies the application development or in the form of testing or in the form of deployment. So you might have or you can say it provides some additional advantage to the developers so that they can develop their applications in the form of any kind of web page deployment, and or you can say any kind of testing in that specific web page, or you can say if your project is ready, or you want to deploy it to different environment like CentOS based environment or uh, Ubuntu based environment. So you can test it running your application into different environments so that you can reduce your you can say compatibility issues. So later on there is a major you can say disadvantage of your projects have been done in to some different you can say environment, and just after you deploy it to your servers, and this leads to some compatibility issues. So Docker help you to you can say to execute your programs previously after before your deployment part. It will try to execute your project into different environments like Ubuntu based environment or you can say CentOS based environment, so that you can easily execute your project, and you can test out all sort of compatibility issues. So moving further, basically, yeah. So moving further, you can see Docker is nothing but a computer program that performs an operating system level virtualization, that we call it as a containerization. So this is basically you can say it's a operating system level virtualization. You might have heard about the word virtualization, and you can say many times, I guess. So in that, we usually what we does basically we virtually create a multiple operating system. You can say it's not you can say physically created operating system. It is created above your host operating systems. So I will explain you the architecture as well, so that you can get the brief idea about how the Docker are been work, or you can say how are been they are placed in your host operating systems. So later on, your containerization are nothing but your you can say operating system level of application deployed. In that, your applications have been deployed, like let's say you want to deploy any MySQL. So in this container, your MySQL application will be deployed, and in that your operating system will be attached to your MySQL application, so that your operating system will have only that much resources which are required to execute only that much only that specific application like MySQL, and rest all things will not be you can say included in that. So this reduce your operating systems and your the size of your operating systems. Yeah. So you can say this is a very popular tool and it is very trending in today's market. And similarly, there is an advanced version of Docker. You can say it's also trending in the market. We call it as Kubernetes. So you might have heard about Kubernetes as well. Yeah, guys, are you there? Am I audible to
Yeah,
you?
we've heard of it, but I'm
Okay,
not
okay.
sure of. I don't know much about it though.
Okay, okay, okay. So no worries. It's basically so you can say the clusters of containers. So in that there might be different applications of containers. So every containers are attached with some sort of application to it. Let's say you want to deploy any kind of web applications like Nginx, Apache, or any kind of, you can say, Node.js. So these are your applications. So these are attached with your containers. And similarly, you might have some database application like MySQL, MongoDB, PostgreSQL. So these are individually attached to one single containers, and those container works together to form your project. You can say in form of full scale project, and in that your web page will be there, your database will be there to some different containers, your web page will be provided into some different containers. And similarly, your, let's say you are using some cache memory like you can say there are some memcache database which handles the cache memories. So they are basically you don't need to deploy your project into one full computer. Your actual application are deployed to small containers. So these containers takes a very less you can say resources uh, of your you can say your cloud. Let's say you've deployed your Docker into your cloud, or any kind of VMs or into your cloud. So this is a very advantage of you can say using the Docker. So this uses very less amount of application, or you can say very less amount of resources in the form of CPU usage, in the form of memories, in the form of storage, because in the operating system which it uses is basically core centric upon your application which you are going to execute in that container. So let's move further. You can say Docker is one of our greatest invention in 21st century, and it will, you can say, it will be more, or you can say, more famous in coming days as well. So there are some more, you can say, there are some most common components are existing in the Docker is basically the Docker engine, which is nothing but the Docker server, and the Docker client, which is nothing but your client dashboard where you fire the queries for executing the containers, executing some operations, you can say. And there are some Docker registries where your images are stored. So I will let you know what are the images in the Docker as well. So images are nothing but your information of your containers, like which operating system you want to deploy it into your container, like which application also you want to deploy into your container. So those information are provided under your images. So in coming days we will try to explore more in that as well, so how we can create our image, or how we can create our custom image. And we will write our own script for providing the image as well. And the Docker objects are having a very you can say a very common object, which is a container, and the images, and the networks, and the volume. Basically networks is nothing but the connectivity between the containers, and the volume is nothing but your storage, which is need to be attached with your container, so that it is capable of storing some data as well. So moving further, we can see some simple basic architecture of your Docker, you can say. So this is basically your Docker daemon. So Docker daemon is nothing but your Docker server, which handles the Docker client queries. So this queries will be in the form of deploying any containers. Let's say any user want to deploy any container for any database. So like he want to deploy one container for MySQL. So he will fire a query from the client dashboard, and that queries will be you can say triggered to the server of your Docker, and it will try to manage the volumes, how many volumes, or you can say how many size of volume to be attached to that specific containers, and what image to be attached with the container, and which network to be assigned to that specific container. So these are basic architecture of the Docker, you can say. And let's move further. Basically, Docker versus container, where you can see how your containers have been deployed. So starting from this, you can say under your Docker image, you basically define your which CPUs, or you can say how much CPU memory you wanna assign, and how much memories, and how much storage, and which operating system you wanna assign to it. And Docker image stores these all sort of informations, like which operating system you wanna. Yep, guys. Wanna say anything? Yeah. Okay. So basically, as I said, Docker image stores your information about your containers. So like if you want to deploy any MySQL, or you can say any other application, like any web server like Apache server. So in that, your image will store the information about which Apache server you want to deploy, or which version of the Apache server you want to deploy, and which operating system you want to have with along with your image. And those, based on those image, your client will execute this image, and this will be transformed into one container. And those container will be nothing but the executable, or you can say you can say small VM of your specific application. So these container are nothing but your virtual machines. So they are you can say they are very small in size virtual machines, and you can deploy n numbers of virtual machine based upon your resources. In comparison to VMs, this is basically similar to VMs, you can say. That also I will show you how it differentiate between the virtual machines and the Docker containers. So moving further, you can say coming from the history, basically in the earlier session, or you can say in the earlier years, we used to build up one single server, and above that we used to deploy one operating system, and above that we used to install some application which help us to fulfill our needs. And after 2001, we got to know some hypervisor as well. So there was a trend of you can say cloud, or you can say distributed systems, where we used to spin up our virtual machine above one single machine, and one single machine is capable of deploying multiple virtual machines. So this was a trend till 2008. And later on, we can say after the Docker came into the picture, it tries to does is basically, instead of hypervisor, what it does, it has used the same kernel of the operating system which you are using. Like as of now, I'm using my Mac, and above that I can deploy more than 10 or 20 15 virtual machine in the form of Docker containers. So this was not able to happen in the simple virtual machine, because and simple virtual machine uses a fixed amount of resources. Like it should have some fixed RAM, and it should have some fixed storage. And on the other hand, Docker container doesn't has any fixed storage, or you can say fixed RAM memories. It is dynamically allocated as per your application needs. So whenever your MySQL requires some more resources, and it will attach some more resources to it. So dynamically resources allocation are been done in with the help of into the Docker containers. So this is basically it's an advantage of you can say controlling your resources. So in today's world, you can say we are moving towards the Docker containers, because we want to restrict our resources, and we don't want to use access resources, so that it will take some big huge amount of billings and all. So for that case only, we try to use this Docker containers. So these are basically application centric resources allocation have been done in these containers. So guys, you can see these are some binaries and libraries are attached to these applications. So till here, any queries, guys? Yeah.
No.
Okay, great. So basically, why the need of Docker came into the picture? As I said, Docker basically, let's say we have full-fledged project, and we want to deploy an web server, any database server, or any orchestration tools like Ansible. And for that, we need some libraries, and we need some dependencies for having these such application to be installed into one single machine. But what Docker containers does is basically it will try to spin up this web server into one container, and this database into one another container, and some messaging cache memory for any other containers. And for Ansible, it will try to create one another container. So what it will does, it will be attached to with different containers, and it will orchestrate between each other so that they can fulfill their needs between each other. Like any web server required any database, you can say pulling, so it can easily connect between the other containers without having, or you can say without using access resources. So you might have came across with whenever you deploy any kind of virtual machine, and you assign some resources, and let's say you have deployed some application to it, and you know that your application is not using that much resources, but still your resources have been, you can say, have been wasted, and you are not utilizing the optimum of that. So for that, Docker container came into the picture, in that your application uses that much resources which are required for running that specific application. So in this form of, you can say, this reduces the you can say this reduces your you can say utilization of your resources or memories. And similarly, in the earlier times, so whenever we deploy all these application into one single virtual machines, so this leads to some libraries, you can say some libraries got you can say some issues with having some libraries. Some dependency might get collide between each other. So in this form of way, your project can, you can say, can take you to the hell of the matrix from, you can say. So in that, your project might fail in some certain situations. So to reduce your having your multiple application into one virtual machine, this you can say this gives you advantage of having your application into different small containers. So this will leads to having those projects into individual containers. Let's say you are facing some issue into the database, so only that database specific containers will have some issues, not your full virtual machine get some corrupt in that. So this is the advantage of using your Docker containers. So let's move further. We'll skip it, and we'll get to know in that. So basically, I want to take you to very basic difference between the virtual machine and the Docker containers. So here you can see what we usually does. Basically, whenever we spin up our virtual machines, we have some base, you can say, underlying hardware we have, and above that we used to deploy one single operating system. And with the help of hypervisor, like you can say any kind of virtual machine, or any kind of VMware, or open source VM spinning software, like
Excuse me, sir.
yeah, OpenStack. Yeah.
Oh, I'm sorry. For some reason, my audio wasn't working, so I wasn't able to hear anything, and my mic wasn't working either. Sorry about that. So I've been here this whole time. I just wasn't able to hear or speak.
Okay, no worries, no worries. And no worries, I will meanwhile share you the recordings as well, so you can go through with it easily. Yeah.
Okay, thank you.
Great. So where were we? Yeah. So coming to the virtual machine deployment, whenever we try to deploy one single virtual machine, we need to have some simple underlying hardwares. Above that, we used to attach some operating system. So this was the traditional way of spinning the virtual machine. So in that, in the hypervisor part, we used to take some help of some tools like VirtualBox, or you can say VMware software. So these help us to spin up the virtual machines. So in that, what we basically used to do is we define some storage, and we define some CPU memories, and we define some hardwares as well. So in that, it will try to use the hardware which was underlying you can say underlying hardware itself. So it is using this specific hardware itself. So let's say your present operating system is utilizing some let's say you have some 8 GB of RAM and some certain GB of storage. So let's say from your 8 GB, 4 GB of memory is already been utilized by your base operating system, which is nothing but, let's say, consider which is Macintosh. So you are having only the rest of the memory, which is 4 GB of memory, and above your 4 GB you can spin up from that only, from that specific resources only. So let's say you want to assign 2 GB of a virtual machine to one virtual, and another virtual machine will have 2 GB of RAM. So there's a limitation of spinning the virtual machine. So you can't use more than 2 virtual machine here. And very basic thing is it takes some memory utilization is much more, you can say, and booting time is very high, because you are booting above your main single operating system, and you are booting above your main operating system, you are booting one more operating system in the form of virtual machines. And on the other hand, in the Docker container, what it does basically, it tries to you can say it tries to use your operating system above that. Docker daemons have been installed, or you can say in other terms, Docker servers are installed. And basically it is nothing but the Docker package, or you can say you can easily install it into any of your machines. So that also we will try to install, or you can say we'll try to set up a lab into our cloud as well. So we'll try to spin up one machine for Docker itself, and we will try to install the Docker in that. So in that, there is one correction here. So this is not VM1, this is container1, container2. There might be multiple containers. So as per your application. So like this is having some application for, you can say, some web server application, or any database application, or any Jenkins application, or any kind of Ansible application. So this is basically your resources will be attached as per your applications. Like in that, basically they have their own operating system as well, but they are in a very small in size, you can say. So they are basically having only that much binary files in that specific operating system, which helps to run only that much specific application of into your containers. So this uses very less memory utilization in comparison to your virtual machine. So you can see, if you are not using any application in that much amount, still your resources has been blocked by your virtual machine. So here in Docker container, the case is very different. Your virtual machine will only utilize only that much resources, which you can say which are required for running those applications. And similarly, your storage will be very less. Your boot time is very less. You can easily in a couple of seconds you can spin up your containers with some simple Docker commands. So these are the things we need to be aware of between the Docker containers and the virtual machines. So they basically correlate with each other. So whenever you want to jump to any kind of interview, so they will ask you what basic difference are there between the virtual machine and the Docker containers. So these are basic terms, you can say. You can say your it is based on your application centric resources have been used in your container. So this is how it differentiate between each other. So moving further, we'll try now to spin up our you can say one of the machine, and we'll try to set up a lab into it. So let's open our cloud. So till here, guys, any queries?
No.
I'm good.
Right. So now we'll start up with setting up the Docker machine.
Mm-hmm.
So to give you an overview about our Zen cloud, basically this is our cloud having running on a host with 10.10.11. We are having our own private cloud. and it is running above our VPN. I'm expecting you might all have your own VPN profile created to everybody. Yeah.
Yes.
Okay, great. So let's try to spin up one of the machine using the default template. So let's choose this as a default template, and yeah. So let's give it a name. And
We can see a PowerPoint. Are you on the right turn?
okay, let me share that as well. Now, can you see this cloud?
Yeah.
Okay, great. So let's give this VM some name. So we'll give dev. And we are choosing the dev cluster, and this is the basically this is the selection of which data store we wanna choose it. So we have some two different data storage available. So they both are of terabytes of in size. Now we will customize our VM, and we will choose to power on just after we have created the machine. So it should immediately switch on the VM just after it got created. So before that, we need to customize how much hardware we want to assign to it. Okay, let's have one single, or let's say we give two vCPUs, and we give 4 GB of RAM memories, and we'll give a 30 GB. Let's say take it to 60. Yeah. So this is how we have provided the specification. In that we have given 2 GB of vCPU and 4 GB of RAM memory and 60 GB of hard drive storage. So there we have our machine, and it's now getting configured. So let me show you the stats as well. Yeah, it's almost completed. So we are just waiting for IP assigning. So with the help of this IP, we will try to get the access with the help of SSH. So let's wait for a couple of seconds so that it will assign the IPs to this machine. Okay, so we have got the IP of ending with 87. So let's now it's 7. Okay, yes, and providing the password and yeah, there we go. We are inside our VM. So there you can see with the IP of 87, we are inside our VM, which we have just now created here. So now we need to install the our Docker application here. So the very first thing is, so I have some script for installing it. So let's follow that itself. Okay. So we're gonna make some git check. So this will try to update the present repository, which is already existing in this, uh, you can say, in this Yum package manager. So these are some repository like Apple, Base, Apple, Extra, Jenkins. So now it is trying to gathering all these updates have been done. So let's try to install some prerequisite to have our Docker up and running. So most of the things are already installed. So moving further, we need to add the repository of our Docker into our repo files. So let me show you that as well, where we basically store our uh, repo files. So these are basically stored under yum.reposd and docker ce.repo. So here basically what repo file does is basically whenever you want to install any applications, so it will provide in the repo file you basically define your you can say or you can say downloadable package, you will where you can find that package that have been that all sort of information are provided into your repo file. So whenever you want to install any Docker or any kind of packages, so it will first try to search it into your repositories, and if it is existing in that, so it will try to download it from that repo file. So let's try to install the Docker, and let's give it yes, so that so till then, coming to the previous picture, you might have heard these terms. You need to be aware of, you can say, deploying any kind of container. So very first thing is we need to have our Docker image, and thereafter, based on that image, your containers will be deployed. So basically, image only have some information which containers based on that your container should be deployed. So let's say that information in the form that will be in the form of you can say which operating system, or you can say which application is need to be installed in it, and what sort of name should be provided, and which user can be provided in that. So these are information provided under your Docker image file. So yeah, so it's almost done. So let's start the service. Let's check the service before that. So it is not started yet. So it is just loaded. So let's start it. I will check for the status. Now it should be up and running. Great. And now what we will do is basically we will set up to start whenever our machine boots. So it will try to uh, start this service whenever we start this virtual machine. So in this way we have set up this Docker to be get started when my system get booted. So in this way, we have successfully installed the Docker. You can find your version of your Docker. So as of now, we have the latest version of 1.13.1, and you want to check for the version of your Docker client and Docker server. So you can find it with the help of Docker version. And here you can see we have a Docker client running on this with this kernel, which is using by default by the Macintosh as well. And your Docker server is using with some different having some different daemons packages are attached with it. So basically, uh, going inside to Docker help command, we can find all sort of Docker related commands have been provided here. So we'll get to know what all sort of what these command does basically. So coming to this Docker image, Docker network. So the very first thing is whenever we wanna spin up any containers, so the very first requirement is we should have some uh, Docker image, or you can say any image to deploy your containers. So let's try to get the list of Docker image. With the help of Docker images, you can find your list of images which is installed, or you can say which is available into your machine. So as of now, it is having none of the machine here because we have not pulled any kind of images into our Docker. So let's see. There are some two ways of pulling your images. So there is one Docker website where they basically store all these images in the form of repositories. So let me give you to Docker Hub. So this is a website where Docker itself provides the images. So in that we need to sign in, and I guess I've already have some credentials. Yeah. So you need to be aware, you need to sign up in this repository file once, and from here you can easily pull up your images. So let me show you, let's say if you wanna spin up any images for MySQL. So there you can see there is one image with the name of MySQL. So this is a very official image, you can say. It has been downloaded by 10 millions of people. So if you wanna pull this image into your local Docker, you can say machine, so you need to fire this command, which is docker pull MySQL. So let's hit into our console here. So with the help of Docker client, we are trying to hit this query. So this is basically the Docker client dashboard, and here you are trying to pull your image. So very first thing, it has tried to you can say pull those image from your or you can say docker.io you can say website. So from that it is trying to pull your image, and what basically image stores is basically this stores the information about how your container should behave, like what all sort of things should be present in your containers. So now we'll try to list down your images. Oops, sorry, there was a typo. Yeah. So now you can see we have one single image, and this is now we have one single image. We have not started any kind of containers still yet, and based on this image, we can easily run up our containers for checking the container, or you can say for running container information. You can check with the help of Docker container ps, or you can use directly Docker ps command. So from here you can you just need to play around with the Docker commands itself. So in the coming session we will try to spin up our custom images, and we will try to uh, make sure to deploy multiple containers into our clouds. So this all sort of way we will try to move further with it, and we will later on will try to make sure to deploy a Swan cluster, which is you can say a cluster of managing multiple containers. So this should your application in that your application is capable of running whenever your one container gets stopped by any reason, like any network issues. So your application should be up and running. For that case, we need to we can deploy Docker Swarm clusters. So basically, Swarm cluster is has a responsibility of managing your application should be up and running all the time. So this is basically we need to first of all we need to basic you can say you need to make sure our basic should be clear before that. So in that many networks are required and many volumes have been required. So here we have just deployed our one Docker machine, and above that we can easily deploy multiple containers. So in the coming session, we will try to spin up more containers as well, based upon taking some simple applications, and in such a way we will move further. So guys, any queries, any question till here? So you can ask.
Yeah, regarding the installation of Docker.
Yeah.
So for our project in the Xenstack cloud, we were given VPNs individually, but how
Yeah.
do I install this?
Yeah, basically, I can share you the installation codes as well. So
Yeah,
I will
those
attach,
commands.
I
Yeah,
will
but
attach those commands after this session. So
so
after, yeah,
so I just SSH in using the VPN, and then I put in these commands, and I'll be able to install Docker.
yeah, you can easily. I can see you have your dedicated machine given to you.
I don't have a vSphere client.
Okay, so no worries. I will make sure to give you all one dedicated machines, so that you can spin up your application into that virtual machine.
Okay.
Yeah, and in that you can easily play around with your Docker, or you can say you can play around with your Docker container. So you can meanwhile do your assignments in that, so that we
Okay.
can also, yeah, I will make sure to create it by end of the day, and
Sure,
we'll,
sure. Yeah, because that'll help us to in practice. Once we finish your presentation, we can go back and practice on that.
yeah, sure. So I will make sure to deploy each machine for individual one, so you can practice it on that.
Okay, thank
I
you.
will share the credentials as well. Yeah.
Okay, thank you.
Yeah. So rest, any guys? Rest, any queries, guys?
Just that, can you? Thank you.
Yeah.
Appreciate that.
Yeah. And guys, any more queries?
No, sir.
Okay.
I'm good.
Okay. Great then. Enjoy learning. Great day ahead.